A rectangular garden is to be surrounded by a fence that is 40 meters long. If the length of the garden is x meters long, determine an expression for the width of the garden. Okay, so we should know that for a rectangle, the perimeter is 2 times the length plus 2 times the width. The perimeter in this scenario is 40. The length is x, as it says over here. So instead of L, we can use x. And now we just have to determine this expression for W. Okay, so let's isolate W. 40 minus 2x equals 2W, divided by 2 on both sides. And I'll just conclude that, therefore, W is equal to 20 minus x. Okay, for part B, it says determine an expression for A of x, the area of the garden, in terms of x. So A of x, the area is going to be the length times the width. And in this case, the length is x, and the width is 20 minus x. So this would work right here. We can also represent this by expanding. So 20x minus x squared. Okay, we can also rewrite this way if we prefer, although it doesn't matter. Okay, for C, sketch a graph. Okay, there's a couple ways we can do this. First, let me just draw the axes. Okay, and this is x. We can let this be A of x. Okay, so first of all, notice that in factored form, we can determine the x-intercepts by letting y, or A of x, equal 0. And that would result in the x-intercepts being 0 and 20. So that will be 0, and this will be 20. Okay, now the A value, the value right here is A is equal to -1. So therefore, it's opening downwards. And we know also that for parabolas or quadratics, it must be symmetrical. So the vertex must be in between the x-intercepts, like on this axis of symmetry. So it should look something like this. Okay, so we have our x-intercept, we have a vertex here. We know that the midpoint must be the x-coordinate of the vertex, so this is 0 and 20, so this must be 10. Okay, if we want to find out the area here, which it's not asking for, but for sketching it's a good idea if we can get it. To substitute the 10 into the area formula over here, and we would get 10 times 10, which is 100. Okay, so that suffices there. Also, we can say x is in meters. Okay, and A of x is in meters squared. Okay, so for part D, it's kind of tied to part C, but D says explain and justify how you can use the equation of A of x to determine the length that maximizes the area of the garden. Well, we just kind of did that with this example. Okay, we can find like the midpoint of the x-intercept, substitute that into the formula, and we get our area. Alternatively, we could use this formula as well, so I'll show you a different way. We can say A of x equals -x squared plus 20x. Now, the equation of the axis of symmetry is x equals -b over 2a. And in this case, b is, well, actually, let me rewrite this as -x squared. Oh, sorry, I have a mistake. It's -x squared plus 20x. Okay, so b is 20, so it's -20. Sorry, it's messing up a little on my end. So -20, and x, a is -1. So 2 times -1, which would be -2. Divide that, and we get 10 for x equals 10. And simply substitute this value back into the area formula. Something else to recognize here, it's an additional point. How do we know it maximizes without graphing? Well, simply we can just look at the A value, and the A value is negative. Therefore, it must be opening downwards, or it's concave down, which implies that it has a maximum value. And that's it.